In this video, we are going to talk about special types of parallelograms and their properties. So if you remember, parallelograms have two pairs of opposite sides parallel, and there are three specific special types of parallelograms. So all of these three shapes, the rhombus, the rectangle, and the square, have opposite sides parallel. They have all the properties of parallelograms. So their opposite angles are going to be congruent, their opposite sides are going to be congruent, consecutive angles are going to be supplementary, and diagonals are going to bisect each other. Those properties happen in all of these. Okay, they also have some of their own special properties. So the rhombus also has all of its sides being congruent. So not only are opposite sides congruent, but all sides are congruent. Okay, so if this was 5, then all of them would be 5. The rhombus also has diagonals that are perpendicular to one another. Okay, so perpendicular, the diagonals are going to be perpendicular. Okay, so when you put these diagonals in here, this is always going to be a right angle in a rhombus, and the diagonals bisect the opposite angles. So what these diagonals actually do is they split this rhombus into 4 identical right triangles. So if you think of folding this over, these two are exactly the same, these two are exactly the same, all of them are, okay? Because you've got these diagonals that can still bisect each other. So you can see by side, 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 all 4 of those triangles are identical. So then what happens is that these two angles and these two angles are exactly the same. So the diagonal is bisecting that angle. And then this angle here and this angle here are identical, and here as well. Okay, so the diagonals bisect opposite angles. I'm going to erase some of this so I can mark that on there for you as well. But I like to just try to remember that the triangles are exactly the same. So whatever's in this one is also in this one, and in this one, and in this one. And then whatever's here is the same here and the same here. So opposite angles are being bisected by those diagonals. Then for a rectangle, so a rectangle has 4 congruent angles. Okay, so the rectangle 360 divided by 4 is 90. So all of these angles right here are 90-degree angles. That makes it a rectangle. And then the diagonals themselves are congruent in a rectangle. So this diagonal is exactly the same length as this diagonal. Okay, unlike these, you can see in a rhombus, this one is shorter than this one. So in a rhombus, you've got, like I marked up before, where you have this piece is equal to this piece, and then you have this one is equal to this one. In a rectangle, since the diagonals are exactly the same length, all of these pieces are identical in length. Okay, so if this one is 4, then all of them are 4. And then when you have a square actually just takes all of these. So a square is a rhombus and a rectangle together. So it steals all of those properties. It doesn't have anything special on its own. So it has 4 congruent sides because it's a rhombus. It also has 4 congruent angles because it's a rectangle. So all of the angles are right angles. It has congruent diagonals because it's a rectangle. So these two pieces are equal. So all of these little diagonal chunks are equal. And then because it's a rhombus, these diagonals are also perpendicular, and all of these angles are identical since opposite angles are being bisected. So in a square, all of these end up being 45 degrees because they're half of that 90. Okay, so those are the 3 special types of parallelograms. So let's take a look at these and classify each using the most specific name possible. So when we're talking most specific, okay, we would start at parallelogram. And then a parallelogram can be a rhombus if it has all congruent sides. It can be a rectangle if it has all congruent angles. And then if it's both of those, if it has both equal angles and equal sides, then it's a square. Okay, so it would be least specific to most specific. So in this one here, we see identical angles, okay, and then different side lengths. So only opposite sides are equal, and then all of the angles are. So this one is a rectangle. So I'm just going to write congruent angles. This one, we see the arrows on each side. So the arrows on each side means parallel sides. So we have opposite sides here being parallel, and then no marks saying anything about congruency. So this one is just simply a parallelogram. This next one has all four sides with tick marks on it. So 4 equal sides means that it's a rhombus. So I'll write 4 congruent sides under here for the reason why. This one just had 2 sets parallel. And then this one we see equal sides and equal angles. Okay, so equal sides makes it a rectangle, equal sides makes it a rhombus, equal angles makes it a rectangle, both is a square. Okay, so this one is congruent sides and congruent angles. All right, classify each special parallelogram using the most specific name. So if we take a look at this parallelogram down here, so it told us that it's a parallelogram. Then we see all 4 angles are equal, so this is going to be a rectangle. Then use the properties to determine the value of x. So RT is this diagonal. US is this diagonal. Remember that in a rectangle, the diagonals are congruent. Okay, so these 2 numbers right here, or these 2 expressions right here, are equal to one another. So we'll set them equal and then solve. So I'm going to get the x's together first by subtracting 3x from both sides. So 10 equals 2x minus 6. Bring this 6 over to both sides. So we'll get 16 equals 2x. Divide by 2. And we get x equals 8. Then I like to just check it just to make sure, because we know that we want them to be congruent. So let's check our work by plugging it in. So 3 times 8 is 24 plus 10 is 34. 5 times 8 is 40. 40 minus 6 is 34. So we get congruent diagonals. That's good. Classify this shape shown here. 4 congruent sides makes it a rhombus. Then when we take a look at what we're given these angles here. Okay, and in a rhombus, remember that the diagonals bisect opposite angles. Okay, so the diagonals bisect the angles. So bisect means splits into equal pieces. So these are equal to each other. So we would say 12x plus 9 equals 57. And then solve. So we can subtract 9. So we get 12x equals 48. Divide by 12. And we get x equals 4. Again, plug it in. So when we plug it in here, it better be 57. So 12 times 4 is 48. 48 plus 9 is 57. So we're good. Last example. So if we take a look at this parallelogram down here, we see congruent sides and we see congruent angles. So that makes this a square. Then when we take a look at where the expressions are on the sides, okay, which are marked as congruent, and you also know from it being a square that you have congruent sides. So congruent means that we will set these equal to each other, and then we will solve. So I'm going to get these x's together. So I'm going to add 4x to both sides. So 13x minus 3 is equal to 23. Then add 3 to both sides. So we get 13x equals 26. Divide by 13 to get x equals 2. And then again, plug it in. So 9 times 2 is 18. 18 minus 3 is 15. And then we have 23 minus 4 times 2. So 4 times 2 is 8. 23 minus 8 is 15. So we get them the same, which is good.